Hey there, you guys. Today we're going to conduct one big experiment, which is going to involve around 600 to 700 kilos of salt and about 3 tons of water.
And this experiment is going to be about density, but before we begin, we will conduct a few smaller experiments, which will partially reveal the essence of the primary experiment.
Obviously, everyone knows that if an ordinary egg is lowered into the water, it will simply sink because the density of the egg is much higher than the density of the water. Simply put, if we take the same volume of an egg into water, then the egg will be heavier.
However, if we take salt and pour it into a glass, the egg won't sink.
So now, when we start pouring ordinary water into the glass, the egg will gradually begin to sink. Well, since now the density of the egg and the water with salt are approximately the same, the egg is simply hung right there in the middle.
But I believe anyone who's ever opened a physics book is familiar with this experiment, so let's move on to the next one.
Now we will lower different sodas into the water. Although they are different, there is something they all have in common. When we put them in the water, absolutely every single one of these bottles will float.
And what do you think? What is the reason for this? Maybe it's got to do something with density because the video is about it. Well, of course not. I think we all know that bottles float precisely because there is air at the top.
However, despite all of this, if we lower this can in, then surprisingly it will sink. How did it drown if there was air inside of it? How could this be possible? Actually, it's all because of sugar, which is found in all of sodas. For example, a can of Fanta contains 8 grams of sugar, and if we were to take a look at the Sprite, then it only contains 2 grams of sugar. But what do you think? How much sugar is contained into the only jar that drowned? It contains 11 grams of sugar. And therefore, we came to the conclusion that this much sugar is the very limit when a jar sinks. And it turns out, you know what I mean, the more sugar in soda, the higher its density. That is, regular Pepsi is heavier than sugar-free Pepsi Zero.
If we carry out the same experiment with fruits and vegetables, well, some fruits will sink, and some remain floating on the surface. It's also related to density of the items. Oh man, I got it.
Well, now we are moving on to the most important experiment of the day.
Normally, we mix cola and Mentos, but today we'll be mixing salt and water. And in this case, there will be no explosion.
This experiment will have a slightly different idea behind it. We want to make such water in which it will be impossible to drown. I think you all heard about the existence of the Dead Sea. So the main property of this sea is that it is impossible to drown inside of it. So, no matter how hard people try to dive in it, the water simply pushes them out. And obviously a person cannot drown, not because the water is somehow magical, but because it contains a lot of salt inside of it. This increases the density.
And right now, we'll begin building a suitable tank for our experiment.
Help! Get me out of here, huh?
What is he yelling at?
Who cares? Come on.
You guys, seriously! You guys! Hey, we need to glue polyethylene already, hey! Well then, bring the polyethylene. Yeah, you guys. To prevent the water from leaking out of our pool, we need to carefully glue everything with polyethylene. Then after that, we will fill it all with salt, water, and etc. You guys, in fact, we finally completed our, well, pool. And it's time to fill it with water. By the way, there goes our water carrier. Come on, come on, come on. I'm starting to think that the polyethylene will soon tear, and we will have to reshoot this experiment.
Woohoo, alright. Alright, I get it. Hey, Max, wake up.
I wasn't sleeping.
It hasn't been a day. Look over there.
Mikita, I know. Where did you go, huh? We've been waiting for you for 3 hours. Okay, you guys, let's continue shooting. We bought some polyethylene, and this time it will all fit our pool. So you guys, we should avoid mistakes of the previous day and properly stretch out the polyethylene in the shape of our pool. Because yesterday, when we were started pouring water, the polyethylene was in tension and simply cracked. That's how it's going. Well, now, in order to continue the experiment, we need to find out how much water there is so that we can add the right amount of salt in a special proportion. So the depth of our pool is 72 centimeters. The width is about 1 meter by 2.5. In total, we get, in short, about 1.5 tons. Well, as we said earlier, the main goal of this experiment is to make approximately the same concentration of water as found in the Dead Sea. And this is approximately 353 grams per liter of water. Well, since we have 1.5 tons here, we will need about 520 kilograms of salt.
And now I will clearly demonstrate that I can easily drown in this water. Also, I really want to swim. The water is cold. Oh, I would even say it's freezing.
As you can see, Artyom dived and simply sank to the bottom here. But if there was the right concentration of salt, then Artyom would simply not have been able to do so. So you guys, we already filled out, well, about how many guys? 100 packs, right? In short, about 150 packs, and according to my own feelings, I was at the Black Sea recently. The concentration here is much higher. Well, not much higher, but higher already.
Stop showing off.
I was at the sea.
So we powered 250 packs of salt, which is about 250 kilos. And the water is very, very salty now.
So salty that it burns the wounds on my arms and my legs incredibly hard, so like absolutely everywhere. Well, and we decided, why not check it out now? Perhaps we can no longer drown in this water here that we have.
Rock, paper, scissors, and 1, 2, 3. Whoa, it pushes me out very quickly. Earlier when I sat, my bum was going straight underwater, and now...
Hand up. Maybe you're fooling everyone.
Here. We have a lot of salt here. I'm sitting on it. In fact, already it pushes water out a lot. Like that.
But don't think that we're going to stop that here. So to say, like, oh, well, he's pretty much floating on water. No, we're going to put salt in it until it's literally like you stand still and you don't have to swim. I mean, you don't drown. So let's keep pouring here. It's been an hour, and we only have 2 bags left, which means that we've already emptied the other 8 that we had. And we start to have this problem. The salt that we pour in, it stops dissolving because we're almost at maximum concentration, which means 2 bags left, it's just only 100 kilos. Let's try to jump in now, see maybe we can no longer surface then. Oh, the other way around. Perhaps we can no longer sink. First time swimming today. Woohoo! Oh, I didn't drown. I swear. Here. Look, I'm holding on to the water without any problems at all. We poured in how many kilos?
400.
We poured 400 kilograms to 1.5 tons ratio, and we achieved the desired result. So let's try to drown. Come on, drown, Maxime. No, I immediately float to the surface. To show you the success of our experiment, I will now exhale just for you. For those of you who don't know, when a person exhales, he sinks way much faster because there is no air inside. Just look. And so what can we conclude? Well, 1 ton of water will be required, approximately 250 kilograms, a maximum of 300, so that a person couldn't really drown at all. Pretty much a safe pool for children, but not to their eyes. Yeah, well, salt eats away at the eyes, if anybody didn't know. Well, Mamix will always tell you something new. Having said that, this video has come to an end.
Thank you all for watching.
Good luck to all of you.
Bye-bye.